The first category of container classes in Java is a list, which is a container for an ordered sequence of elements with duplicates. Unlike arrays, which are of fixed size, a list can dynamically expand or shrink. Here's an example list of 5 elements. Let's append 8 to it. So 8 means append 8 to the end. So the list becomes 2, 4, 1, 8, 12, and 8. Now let's add 9 at a particular position, so position 2. So 9 is going to be added at position 2, and everything from position 2 onwards will be shifted one position to the right. So the list becomes 2, 4, 9, and 1, 8, 12, and 8. So everything was shifted one position to the right. Now I'm going to remove the element at position 3. So starting at 0, 1, 2, and 3. So the red 1 will be removed. And after 1 is removed, everything afterwards, after that will be shifted one position to the left. So this is the final list, 2, 4, 9, 8, 12, and 8. List is a generic interface in Java. You could find all methods in this list interface by following this documentation. I just wanted to list some of the most more important methods in the interface. So we could just say add and append one element to the end, add an element at a particular position, remove an element at a particular position, or find and remove an element. Do a forward search index of element, so that returns the index of the element if it exists, or last index of is a backward search. We could clear out the list, check if it is empty. We could get the first element, the last element, or element at a particular position, and the size. Here is Java list inheritance hierarchy. List is an interface. There are 3 concrete classes that implement the list interface: ArrayList, Vector, and LinkedList. As you can see, all of these concrete classes also implement the iterable interface so that we could iterate over the elements of these concrete classes. Let's now instantiate an object of an array class and store the reference variable in a list of integers. Remember, for the sake of polymorphism, we should always use interfaces or base classes on the left-hand side rather than concrete classes. Initially, the list is empty. We are going to append 10 to it, so the list becomes 10. Append 5, list becomes 10 and 5. Now add 7 at position 1. So if we add 7 into position 1, 5 is now shifted one position to the right. Add 9 at position 2. So if we add 9 at position 2, 5 is again shifted one position to the right. Give me the index of 7. If you look at this, the index of 7 is 1. Get me the element at position 3. So 0, 1, 2, 3. That would be 5. Remove the element at position 1. So if you remove 7, the list becomes 10, 9, and 5. What is the size of the list at this point? It is 3. Is it empty? No. Let's remove the element at position 0. That would be removing 10. So the list becomes 9 and 5. Let's clear the list now. So that removes everything, all elements in the list. And if he asks, is the list empty now? The answer is true because there are no more elements in the list. If I just change the concrete class from an array list to a linked list and run the same test, you're going to get the same result. That is the beauty of polymorphism, that you have 2 concrete classes that implement the same interface, list interface, and they behave exactly the same. The only difference is array list uses an array as the underlying data structure, and linked list uses a linked list, a double linked list as the underlying data structure. And array list is more suitable if you want to get an element at a particular position in order one time. And linked list is more suitable if you are inserting or adding elements mostly at the beginning. Here's some actual code that I would like to go step by step and show you how list behaves. I am instantiating an array list. You don't have to specify the initial capacity, but I am specifying it in here. So if you don't, then it will have a default initial capacity. So let's instantiate the list. Ask what the size of the list is. Obviously, it is 0. Append 3 to it, and list becomes 3, as you can see. We just initial empty list, appended 3, list becomes 3. Let's append 2 to it, so the list becomes 3, 2. Let's append 5, list becomes 3, 2, 5. Let's append 7, it becomes 3, 2, 5, 7. And finally, let's append 1 and 9, so the list becomes 3, 2, 5, 7, 1, and 9. Now I'm going to add an element at the beginning. So I'm using the second add method where I'm specifying the position to which the element should be added. So 6 will be added at position 0. This is the list. Now 6 will be appended at the beginning of the list, and let's print it out. And now you can see 6 has been added at position 0. I can use the get method to get an element at a particular position. So I would like to know Give me the element at position 2, so that would be 2. And give me the element at position 5, that would be 1. So let's print it out. So the element at position 2 is 2, and the element at position 5 is 1. Let's continue. Let's now start removing elements. I'm going to remove the last element from the list. So this is the list. If I remove the last element, this should be gone. Let's look at it and print the elements. And there you go, 9 is gone. So let's remove the element at position 3. That would be 5, as you can see. So we're going to remove the element at position 3, and 5 is gone. Now I'm going to add 4 into position 2, so 0, 1, 2. So 4 is going to be inserted or added at this position, and everything else will be shifted one position to the right. All right, so this is how ArrayList behaves. And if I just change the concrete class from a ArrayList to a linked list, you're going to see that everything works exactly the same as before. So ArrayList and linked list behaves exactly the same. So the only difference between those two concrete classes is that is in terms of performance. Again, this ArrayList uses an array as the underlying data structure. Linked list uses a double linked list as the underlying data structure. So if you have an application where you would like to get an element at a particular position in the list in all one time, you should always use an array list. But if you have an application where you're inserting or adding a lot of data or elements at the beginning of the list, then you should definitely use a linked list.